Hi everyone, my name is Hanin and I'm gonna do the question 1 of homework 5. Let's begin. So it tells us that z equals to x plus y and x and y are independent, so we can just use the formula like fz equals to the integral from minus infinite to infinite fx alpha times fy z minus alpha d alpha. And we just substitute the fx alpha and fy alpha into it. So fx alpha equals to u alpha minus 1 minus u alpha minus 2, and fyc minus alpha equals to u z minus alpha minus u z minus alpha minus 1. And we can just simply expand this equation. So there will be 4 terms. The first term is u alpha minus 1 times u z minus alpha, and the second term is u alpha minus 1 times u z minus alpha minus 1, and the third term is u alpha minus 2 times u z minus alpha. The fourth term is u alpha minus 2 times u z minus alpha minus 1. And we can calculate each term. The first term, it will be 1 when alpha is larger than 1 and smaller than z. So the interval of it is from 1 to z, and we have to make sure that z is larger than 1, so we have u z minus 1 after the integral. And similarly, the second term we can write it into from 1 to z minus 1, and we have to z minus 1 have to larger than 1, so it will be a u z minus 2. And the third term will be from 2 to z, and we will have a u z minus 2. And the last term will be 2 to z minus 1. And we will have u z minus 3, sorry, so it's u z minus 3. And then the final result will be z minus 1 times u z minus 1, and minus 2 times z minus 2 times u z minus 2 plus z minus 3 times u z minus 3. So that's the final result. Okay, that's the convolution method for sub-question 1, and for sub-question 2, it tells to use the geometric method. And here we can consider in a simple way. We can just let fx equals to ux minus ux1, which is the original fx shifting left by 1. So in the result, we will have to shift right by 1 to make it back to original. So fz equals to the probability of z is smaller or equal to z, and equals to the probability of x plus y is smaller or equal to z. So use this, we can derive an area, so that we can use a geometric method, like we use the shadow area to divide it by the total area, so then we can calculate this probability, and then we will have the fzz, the distribution function, and then we will have the density function. So for the z larger than 0 and smaller or equal to 1, so we will have this graph, this figure, that z is smaller than 1, and we know that xy is actually a uniform distribution from 0 to 1, so the total area will be rectangular, which size is 1, and the shadow area here is 1 over 2 times the z square. So here fzz equals to the probability of it, and the probability equals to the shadow area divided by the total area, and it is equal to 1/2 times z squared. So we have the density function is the derivative of it, it's just z. And for the second case, when z is larger than 1 and smaller or equal to 2, here we have this kind of figure, z is larger than 1, so it's over it. And we still calculate the shadow area divided by total area. Well, the shadow area here is the total area of this rectangular is 1/2 times z squared, and there are two small squares like here and here, so it's times 2 times 1/2 times z minus 1 square. So the shadow area is this divided this this minus this, and it is minus 1/2 times z squared plus 2z minus 1, and we calculate the derivative, and the density function is derivative of it, and it is minus z plus 2. And like I said before, we should shift to the right by 1 to derive the final result. So the density function will equal to z minus 1 when z is larger than 1 or equal to 2, which is the first case, shifting right by 1. In the second case, shifting shifting to the right by 1 will be minus 2 plus 3 when z is larger than 2 and smaller or equal to 3, and it will equal to 0 otherwise. So we can easily verify that it is equals to the this equation, like the result of the first. So we know it's the right answer for the density function of z. So that's all for the question 1. Thank you.